Hello friend, welcome to the class. Today we will discuss A-level mastering differentiation and understanding the rate of change and the power of rules. In this part we will check 2 points, that is power of rules and understanding the rate of the change. So first concept is what is the gradient, then mechanics, the power rule and the exam mastery A-level applications we will also discuss in this chapter. So let's go ahead and see the different topics. Like calculus is the mathematics for exact moment, and where we use in physics the pinpoint exactly velocity and acceleration. In economics, calculating marginal cost and profit shift. We will also discuss this calculation application. And in engineering, we see the optimized structure limits. Then we have a computer science training, machine learning algorithm. Differentiation is the key, how we can determine the exact speed of the object at a single frozen moment in the time. So all these things will be determined using the mathematics calculus parts of differentiation we will discuss. Then the pre-flight checklist we will discuss, like indices, algebra, graphs, and here geometry part. Indices x square into x cube, that is x to the power 5, fluency index law. And algebra we will like to 3x 2x plus 4, the first algebraic manipulation. Then graphs y equal to x square, visualizing standard functions. Then geometry we have to calculate this coordinate and gradient we will also discuss in this part. And for second to tangent rule, the instantaneous rate change, like here the position from this second line and to this one, fx y equal to fx, the rate change in the average rate change. Here second it's t2 points, the closing the gaps, and this is a single tangent point, instantaneous tangent. So f dash x we can write dy by dx, the master key to gradient, that is dy by dx at given point. Antony of the power of rule, what is the power of the when the dy by dx x to the power n equal to n x to the power n minus 1. So if you differentiate this one x cube, we will find here 3x square, the power will be multiply and the one power is subtracted, power 1 in power 1 is subtracted. Here 5 is multiply and that will be minus 1. So 5 minus 1, that is 4, and here 8 is a multiply and power is less, 8 minus 1, that is 7. Bring the power down to the multiply. And the polynomial assembly lines, like 4x cube plus 2x square minus 5x plus 7. So these are the terms. We have to just f y dash. Y dash means dy by dx. First power is a multiply, so 4 into 3, 12. And 3 minus 1, that is 2. Here 2 into 2, 4, and 2 minus 1, that is 1 power. And here is only minus 5, and constant term we have 0. So it will be vanishes. Okay. So dual nature of calculus, the original function y equal to fx and derivative of function y dash is f dash x. The position or exact value and steepness ratio of the change. The curve states and is its a tangent slope, distance travel and speedometer reading. So all these things will be calculated by this one. The derivative not just a number, it is a new master functions that map the gradient everywhere. Work example, multiplying coefficient, differentiate y. So 4 into 7, that is 28, and 4 minus 1, so this is the law. 4 into 7, 4 minus 1, and this is the 28x cube. When we are bringing the power down, always multiply it by existing coefficient. Okay, so in this way you can calculate anything. I hope you can guys understand easily, and if you need any kind of help or you have any suggestions, just drop comment below and I will surely include in the next video. So let's do the next further classes. Example 2, we have a 3x is to the power 5 plus 5x cube minus 7x plus 4 here. So 5 is multiply 15 and 5 minus 1, that is 4. Here 3 into 2, that is 6, and 3 minus 1, 2. Here minus 1 is 7 and this will be vanishes, that will be 0. Suppose find the gradient of y 2x cube minus x square plus 4 when x equal to 2. So first differentiate, it will be 3x square and this will be 2x. Now substitute the arithmetic like x equal to 2 here, so it will be 2 square and 2 into 2. So include the geometry, so gradient will be 20. Critical exam text, always differentiate the function before substitute the value of the x. So always first differentiate, then we have to put the value of 2 in this part. Danger to common pitfalls, where is missing, what traps, differentiate a low number like 8, writing at x, it's become absolute 0. Differentiate linear number, writing 0 or 5x, x drop entirely leaving just the coefficient 5, and negative polynomial terms, forgetting the minus sign when bringing power down. A circle the negative sign with your pen and before multiplying. Okay, so these are the some pitfalls or danger zones, so we should remember to while differentiating. Then frequency, the two language of the calculus like fraction style y equal to dy by dx, and prime styles like fx and f dash x, like this one. This is written in this one and this is this one. The predict the exact coordinate where this curve completely flat lines by x square. So first what we have to do, just we have to differentiate, that will be 2 minus 4, then substitute the gradient 0, so where x equal to 2, where x equal to 2. So in this way we can finding where gradient equal to 0 is key to optimization, and finding maximum and minimum value we can find from this one. Differentiation blueprint, like this is x to the power n, so n is a multiply and power is a less, drop new coefficient in this one. So f dash is a def by def. Differentiate algebra, substitute arithmetic and conclude, that will be geometric. Next steps, solidification foundations like dy by ds y equal to 5x cube minus x plus 9. So what will be, it will be 5 into 3, 15 x square, 3 minus 1 2, so it is x square, and this will be minus and x will be 1, so it's a differentiation in 1, and this will be 0, and this will be 4 into 2 8 x to the power 3, and when you put the value of here 3, so 8 into 1, that is 1, that is 3. Explain why derivative of 12 is 0, because when you multiply x to the power 1 and 1 is subtracted, their power will be 0, so its value is also 0. So x 1 upon x square plus x cube, so in this way we can calculate, and further in the class we will discuss about this topic. So I hope you understand these topics and you have some clear visibility about these topics. I will further take a new part of this differentiation, and we will run a full playlist. If you like this video and you like more such kind of videos, please like, subscribe and follow my channel. Thank you so much guys for support, and
like, subscribe and share.